What's up, guys? Welcome to this brand new video where I'll be showing you how to deploy a fashion product recommendation app on Google Cloud using Gemini Pro Vision, which is Google's latest multimodal LLM offering. Now, before we begin, just a quick background on what's Google Gemini, which most of you guys might have already heard of, if not all. Basically, Gemini is a family of generative AI models developed by Google's DeepMind, and it has two variants which are generally available as of today, which is the second week of March. The first one is Gemini 1.0 Pro, which is an LLM that is designed to handle NLP tasks, multi-turn text, code chat, and even code generation. And the next you have Gemini 1.0 Pro Vision, which is meant for multimodal use cases, meaning you can input multimodal prompts such as text, images, audio, videos in your prompt request, and you can get textual or even visual responses back. And Pro Vision is what we will be making use of in this lab. So that was all the theory that was needed for this lab. Now let's understand the context of what we are going to build. So imagine working for an e-commerce company which sells sneakers with a catalog containing thousands of products. Now, in order to improve the shopping experience of the customers, you've deployed a chatbot which will interact with the potential customers and recommend products based on their preferences and choice. Now, imagine a guy who's looking to buy sneakers specifically matching his preferred outfit, which is a white t-shirt and denim jeans. So he opens up the chatbot UI and uploads the picture of this outfit, which is a white t-shirt and blue denim jeans. And the model recommends different sneakers available in the inventory matching his preferences. Now in this flow, first of all the product images will be uploaded to a GCS bucket. The second step is to accept the inputs from the user, which will be passed to the Gemini Pro model in order to match the user inputs against the product images stored in the GCS bucket, and eventually come up with accurate recommendations, which in this case can contain image and text both, or either of them, since Gemini Pro is multimodal. So adding to this example, our LLM model will accept two inputs via the Streamlit app. The first one is the text input, which in this case could be, I'm looking for sneakers matching this outfit. And the second input is basically an image upload button using which the user will upload the image of his outfit or her outfit. Alright, so this is what the Streamlit app looks like. On the left hand side is a space for you to accept the user inputs. So this is the text input, and this is where you can upload the image. And right at the center is where you will see the response from the LLM. Now the app is quite simple. I have not designed it at all. I've just used the basic Streamlit functionalities. The execution is very simple as well, and you'll learn that when we get to the execution bit. But the idea is extremely powerful, meaning you can expand upon this idea with a little bit of software development or data engineering skills. So let's see how this works. So I'm going to say I'm looking for, let's say, Nike sneakers matching this outfit. Now let me upload an image. I'm going to upload a JPEG image. And you can say it has started processing, and it describes the uploaded image first. It says the image shows a t-shirt and trousers. The t-shirt is gray and has a Nike logo on it. And the trousers is beige and has a cargo pocket on the side. Now let's give it a bit. And that's your output. So you can see the output has two parts. One is the text, which is where it says, I found 3 Nike sneakers that match your outfit, so on and so forth. And it's describing the three products that it has selected. And right at the bottom, you see the images. Now this entire thing is an image. There's no text. Now there's text inside the image, just so you know. All right. So you have the text here followed by 3 images. So that was your multimodal response from Gemini Vision Pro. Let's try to change the request. Now instead of Nike, I'm going to say Adidas. And let me try to request 2 sneakers specifically, just to see if the LLM respects the user input. So I'm going to say suggest 2 Adidas sneakers matching this outfit. Now let me upload a different image, which is white t-shirt and denim jeans. All right, there you go. So you have the image description, which is just one line, blue straight leg jeans. And then you have your text response. It says, I've selected two Adidas sneakers that match your outfit. The first one is Samba OG shoes, so on and so forth. And you can see it is only recommending two Adidas sneakers. All right, so let's get started with the development. For development, I'm going to begin with Jupyter Labs or Jupyter Notebook, which is where we'll be developing the entire end-to-end code. Once the code is done and we're through with it, we'll be deploying this as a Streamlit app on Compute Engine on GCP. So you need to spin up a workbench on Vertex AI from your GCP console. So you can see I've created a workbench called LLM Workbench with the environment set to Python 3, which comes with scikit-learn, NumPy, SciPy. And I've selected the smallest possible machine type, which comes with two virtual core CPUs and 8 gig RAM, which should be more than enough for us to be able to perform all the steps in the lab. So go ahead and create this, and once you're done, you can click on Open Jupyter Lab, which will open up a Jupyter kernel, as you can see. Now, all the code and the images necessary for this lab can be found in my GitHub repo, which you can find in the description of this video. So go ahead and download all the necessary files and images. And inside of it, you will see sneaker recommendation.ipython notebook. So once you are inside your workbench, just click on this upload button and upload the necessary IPython notebooks. Now, before we start with the execution, I want you guys to upload all the images to a GCS bucket. I've created a bucket called LLM Demo V1. Inside of this, create two folders, Sneaker Collections, which is going to have all the images of the products, and then User Input Images. Now, this subdirectory, User Input Images, is only going to be used for Jupyter Notebook development. When we move to Streamlit app, we will not need this because the user will upload the images dynamically, which will be processed at runtime. So this is only for the sake of demonstration. So go ahead, create both these subdirectories, and inside User Input Images, upload the two files, input1.jpg and input2.png. And inside Sneaker Collections, you need to upload the 10 product images of 10 sneakers, 5 for Adidas and 5 for Nike. Now, for the sake of demonstration and simplicity, I'm only limiting this application to 10 images, but you can feel free to add more. All right, so that was that. Now let's open up sneaker recommendation. First of all, you need to upgrade your Google Cloud AI Platform module from within the notebook. Just uncomment this line and run this pip3 install command. It's going to take a couple of minutes. Once that is done, you can click on kernel and just restart it once. So let's begin. We import the necessary libraries. We need Vertex AI, we need the generative model, because this is the library inside of which you will be able to invoke all the LLMs offered by Google. We need storage, IO.json, we're using PIL, which is a Python imaging library, which is a handy library when it comes to manipulating images. Next, I have project ID, location, and I initialize my Vertex AI. This is my bucket name. Now I create an object called multimodal underscore model, which is an object of generative model. And inside of this, we pass the name of the LLM that we want to use. Simple. So it's Gemini 1.0 Pro Vision, which is what we plan to use in this lab, right? Next, I have a simple utility function called load image from GCS. And as the name suggests, it downloads images from your Google Cloud Storage bucket, converts them into a byte format, and returns it. Now, the byte format is needed because Vertex AI expects images to be converted to bytes, all right? And this is where we're making use of PIL if you go through the function. So let's execute this code block now. Next, we define our product images inside a Python list called sneaker image paths. Now you can see these paths are relative paths of the images. Sneaker collection is the name of the subdirectory where we have stored the input images. You can see sneaker collections. And once we create the list, we just invoke the function load image from GCS, which has been defined above. All right, so my variable sneaker underscore images will have all the images loaded into it. Let's run this. Next, we do the same for the input image. So I'm using input1.jpg. You can use input2.png as well. Doesn't matter. They're two different images. Or you can create your own as well. So I do the same, and the input image will be stored inside input underscore image. So let me run this. All right. Next comes the prompt. So we create a variable called prompt where we want the LLM to describe the input image. So I'm saying describe just the t-shirt, shirt, trousers, or jeans in the picture briefly. And then I create a variable called contents, which is a Python list. It has two arguments, prompt and input image. Prompt is what we've defined above, and input image in this case is input1.jpg. All right. So once our contents list is ready, we just pass it to the generate underscore content method, which is a function inside the multi-modal Gemini Pro Vision library. Okay, so you need to invoke this method every time you want to generate content. Now we set the value of stream to true for streaming outputs, and once we get the response, we just run a for loop and parse the text key from it. So let's run this code block to see what happens. All right, so you can see the description as asked. You can play around with this prompt. You can even ask the LLM to describe it in 10 characters or 10 words or 15 words and whatnot. So it says the t-shirt is gray, Nike logo on it, so on and so forth. In the next code block comes the main prompt, which is the prompt to the LLM, which is what we'll be using in the application as well. So I'm saying you're a fashion expert. Recommend two Adidas sneakers, which would go along with the input image. Respond in JSON with two keys, explanation and image path. Let me add a colon here. And the last two lines are extremely important. So I'm saying the output format must be strictly a JSON string in the below format with no illegal string terminations and must be inside quotes. And I've also given an example here containing two keys, explanation and image paths. All right, and we'll see why I'm doing this. So this is my prompt, and next comes my content, which is a Python list, as we know. Now inside this list, this is where you enter your text and input and your prompt, and there's no specific sequence in which you need to enter this. All right, so you can start with image followed by text prompts, or you can start with text followed by image followed by text, so on and so forth. There's no specific hard and fast rule that you must follow. So in here I'm saying consider the following sneakers followed by the 10 sneakers that I have up until index 9. All right, so the sneaker underscore images variable, we know it has the 10 images starting from 0 through 9. So I give the name of the sneakers followed by the image itself. And this is very important because we need to pass the image to the LLM model, right? And here I specify the absolute path of my image. Okay, and this is important because the LLM does not know the location of my image inside my GCS bucket. It does not know anything. All it can see is the name of the product, which is, let's say, Nike Air Max 1, and the image itself. Now, unless you pass this path, it's not going to be able to return it back to you, which is what is expected in our case, because we plan to display the output, right? We plan to display the images depending on what the LLM recommends to the user. So that's the purpose of hard coding the image path here. When it comes to production, you can easily make this whole thing dynamic using simple Python development. You can make this entire, even the names, the price, you can add more attributes if you want. So it's quite simple. Finally, I also pass the input image. I've used an attribute called input image, which is not absolutely needed, but this is just for the model to know this is the input image. And right at the end, I pass the fashion expert prompt, which has been defined here. All right. Then it's pretty much the same. We invoke the method generate underscore content, and we pass the contents list to it by setting the stream value to true. Now in here, which is the last for loop, I'm just doing some string manipulation because I know the response is not going to be in a format that Python can utilize it directly, all right? Which is why there is a need to clean the string, remove the white spaces, so on and so forth. So let's run this code block and see what happens. All right, there you go. So you can see we have received a dictionary containing two keys, explanation and image paths. Now this image path is basically a list, which is what we want, so we can pass through it of two images separated by comma, obviously. Now, if you click on any link, let's say, it's going to open up that specific image, which is exactly what we want again. Now, how do you do it? In order for you to be able to access the images, the objects in your bucket need to be made public. So how do you do it? Just go back to your bucket, click on permissions, click on this button, grant access, and inside new principles, just type all and select all users. In the select role drop down, you must select object reader, which in my case won't show up because I've already granted the permission, but in your case, you should be able to see storage object reader, not the legacy one, but the other one, okay? So select that role and click on save. I've already done it, which is why it's not appearing here. And once that is done, you should be able to access your image. So after this, I just convert it into a JSON format, so you can see this. And if I output image paths, you will see the two values which the LLM has recommended. I hope that was quite straightforward. Now, one thing you might have noticed here is that if you look at the prompt, which is fashion expert prompt, this is the prompt that will be passed to our LLM model no matter what, all right? So this is a static prompt which does not change. And in this notebook, we have not allowed for a dynamic prompt, right? Which is what we need to accept from the user. The text area that needs to be accepted as an input from the user is not here in this notebook. Now for that, you must open recommendations with user input, and 99% of the code is exactly the same. So keep scrolling down and you will see that I have split the fashion expert prompt into three different variables. The first one is called user input prompt. Now this is the prompt that will be dynamically accepted from the UI. Since we are using a Jupyter notebook, I've hard-coded the user input prompt by saying, I'm looking for Adidas sneakers to go with these cargos. All right, so assume this is what the user is saying. And next comes the instructions prompt, where I'm saying, fetch the colors and the product price first, then only select 3 to 4 products that match the user preferences. If no products are found, then say, sorry, we do not have products matching your preferences. Think step by step before responding. The user says, and this is where I pass the user input prompt, okay? So you can see I'm using an f string in Python. F string is a way of defining a string by passing or by allowing for dynamic variables. And the dynamic variable in this case is user input prompt, okay, in curly braces. So that was my instructions prompt. And finally, I have my output prompt where I specify the output format. And I've just kept the prompt a bit more structured in this notebook by coming up with points or bullet points. You can see bullet point 1, I'm saying respond in JSON with two keys, explanation and image path. Point number 2, explanation must be your response to the above user request, so on and so forth. You can go through it. And then finally, the output format, which we've already seen. It's exactly the same, where I give the example and I tell the LLM what should be the format of the response. And the rest is the same. Over here in the contents Python list, I pass the input image, I pass the instructions prompt, and then I pass the output prompt. Keep in mind, instructions prompt has the user prompt as well. So that's the only difference here. And the rest is pretty much the same. So you can Click on kernel and just say restart kernel and run all cells. Alright, there you go. So that's the output. It has explanation. It says I have found 3 Adidas sneakers that match your preference, and these are the links to the images, which is quite weird because it selected Nike Air Max 1, Nike again, and the last one is Adidas. But yeah, this is something you must expect from LLM. They are not 100% accurate. Maybe a bit more of prompt engineering might be needed here, where you apply some strict rules and tell the LLM to respect the user request or the user input and not reply anything outside of what has been asked. So I hope the idea was clear. The execution was simple as well. Now let's move on to deploying this model to Compute Engine. Okay, so let's start by creating a virtual machine. So I'm going to type Compute Engine from the console. And on this page, click on Create Instance. Let me give this a name. I'm going to call this LLM Demo P1. For the region, I'm going to leave it as the default. E2, which is a general purpose machine, is more than enough. For the machine type, I'm going to select standard with 8 gig memory. And let's scroll down. Under boot disk, click on change because I want to use Ubuntu. 20.04 LTS. Size of 10 GB or storage of 10 GB is more than enough. So let's click on select. Now under access scopes, I'm going to select allow full access to all cloud APIs. And under firewall, I'm going to check the first 2 boxes for HTTP and HTTPS traffic. And that should be good enough. Now let's click on create and give it a couple of minutes until the virtual machine gets created. Alright, so my compute engine is up and running. It barely took a few seconds. Now against this compute engine that we've just created, you should see a drop down. Click on it and select View G-Cloud command. Now this is going to give you the G-Cloud command to SSH into your compute engine that you just created. Which means in order to be able to run this command, you need the G-Cloud SDK installed in your local system. So if you haven't done that already, go ahead and install the G-Cloud SDK so that you can execute G-Cloud commands. And it's quite simple regardless of the operating system, Windows, Ubuntu, Mac. So once you're done, you can come back, copy this command and paste it here. Alright, so I've successfully logged into my compute engine, and if I do an ls, I should see nothing because there's no files, no directories, nothing at all. Now open up the file commands.sh, and inside of this bash file you will see 3 commands. The first one is update, the second one is apt install python 3 pip, which will install the pip module in your compute engine, and lastly you will do a pip install in order to install Streamlit version 1.25.0 and the Google Cloud AI platform as well. So run each of these commands one at a time after you have SSH'd into your compute engine. I've already done it, but I'm just going to show you how it's done. So update is done, followed by Python 3 pip. Now, after you have executed the second command, which is installing Python 3 pip, just type pip and hit enter, just to make sure you don't get a command not recognized error. In this case, pip has been installed successfully. And finally, I'm going to do a pip install. All right. So that was that. We have installed all the necessary libraries. Now the next step is to upload or import app.py, which is our Streamlit app, to into our compute engine. But before that, let's quickly go over app.py. Now this is exactly the same code that we have executed using the Jupyter notebook, all right? Except you will see I have tweaked this code and turned it into a UI. That's pretty much it. It has a form which you will see inside the main function. And I've added basic titles and headers and so forth. That's pretty much it. Now coming to the part where we had hard coded the input image when we were executing the code from Jupyter Notebooks. In case of Streamlit, I have written a function called load image from upload, which will actually take the uploaded file dynamically from the UI or from the front end and then generate the byte format of that specific image. So that's the only difference. And you will see another function here which is called display image from GCS, which is basically going to display the uploaded picture onto the UI. That's all it does. Okay, the rest of the code is pretty much the same. As you can see, the prompts are the same, the responses, the way it is handled, everything remains the same. So that was your app.py. Now, let's open up a new tab. And now I'm going to show you the command to upload app.py from your local system to your instance. And this is the one that says gcloud compute SCP. SCP is copy, followed by the file you want to copy, which is app.py in this case, followed by the name of my instance, colon, dot. Dot is the working directory or current working directory or the root directory in this case. So I'm just going to copy this command. And before running this command, just make sure your app.py is in the current directory wherever you're executing the command from. So you can see I have my app.py here. I'm just going to run this. All right. Now, before you copy app.py from your local system to the compute engine, I forgot to mention this. You must make sure that you change the project IDs and the bucket names and whatever other variables that apply only to you. So make sure you change the necessary variables and then move the file or copy the file to your compute engine. So the file has been copied. Now let's do an ls again. You should see app.py here. All right, so if I just do a streamlit run app.py, there you go. Okay, so this is my external URL, but we are not going to be able to access this as of yet. We need to make some basic firewall changes, which is what we'll be doing next. Now let's go back to console and type firewall. Let's click on it. Now in here, click on create firewall rule. Let's start with the name. I'm just going to call this LLM demo public access. Scroll down. Direction of traffic. This is for incoming traffic, right? So ingress it is. Allow and match allow. Under targets, click on the drop down and select all instances in the network. And for IP range, we are going to allow all the IP addresses across the globe to be able to access this application. So for that, I'm going to type 0.0.0.0/0 again. And protocols and ports, I'm going to say allow all, but you have to be really careful with these firewall rules when it comes to production environments. Now let's click on create. All right, so that was that. Now let's grab the IP address from the terminal. And I'm going to go and open it up in my Firefox browser. So there you go. There you have your app up and running. You can try out different prompts. You can even upload the images, create your own images. I would even recommend changing the prompts and doing a bit of prompt engineering, especially playing around with the contents Python list, which is on line number 135 of app.py. So that was that. I hope you guys enjoyed it. Please like and subscribe. This really motivates me to create more labs. The idea here is to create at least 2 labs per week. Thanks a lot for watching.